Okay, so before others join us, let's just try to get exothermic with these questions. Okay, so to just test what we learned on properties of metals quickly. Don't forget, you are going to be having 40 objective questions. This is third term exam, 40 objective questions, powerful one. Okay, sorry. I had network issue. Okay, so before others fully join, let's focus on these questions. I'll just take one or two, then I'll move on to the next thing. One or two. Yes. Which statement about the use of metal is correct? Yeah, you can see these questions, they can be very trickish. Yeah, anyone? Quickly. Yes. Who is answering question one? Yes, Toby Obalola. Go ahead.
I think is D.
Did you say D?
Yes, sir.
Okay, stainless steel is used in the construction of chemical plants because of its strength and resistance to corrosion. Yes, any other person? Yes, Toby has given us a view. Which other option are you considering? Okay, so D is correct. If you look at A, aluminum is used manufacture of aircraft because of its what? Low density, not high density. So the answer is D. Yeah, number two, quickly. Number two, so stainless steel. Of course, we know steel from iron. Steel is made from iron. Stainless steel, because of its what? Resistance to corrosion. And of course, steel itself is what? High strength. Number two, quickly. Number two, three properties of copper are given there. Which property makes copper a suitable metal? Yes, Farida.
I think the answer is A, 1 and 3.
1 and 3. Corrosion to resistant, good conductor of heat. Okay? As a cooking pot, it won't be good conductor of electricity. So it is good conductor of heat. So 1 and 3 correct. Okay? Let's take one more. Which property is not correct for copper? Copper is a transition element used to make saucepan. So which of these three properties will not be correct for the use? Yes. Is that Ini? I can't read that sign well.
Yes, sir, it's me.
Okay, go ahead. C, low melting point. C, low melting point. Okay, so low melting point. Let's make progress. That's on properties of metals. Now, the big guy, alloys. Now, alloys is very simple. Alloys and their properties. Your learning outcomes want you to be able to, number one, describe an alloy as a what? A mixture of metal with other elements. So you can describe, if you say, explain the term alloys. Explain the term alloys. Alloys are mixtures of metals or mixtures of what? Metals and non-metals, such as carbon. Do you get it? So we can make alloy by mixing two metals together. For example, bronze. Bronze is what? Copper plus what? Tin. Bronze. Bronze is what? Copper plus what? Zinc. Please, you need to know a few examples like this. Steel. Steel is what? Iron and what? Carbon. Right? Stainless steel. Stainless steel will be what? Iron plus carbon plus chromium. You know, it goes on like that. Palladium, every other rhodium, metals that have, high resistance to what? To corrosion, right? Chromium, nickel, and all that, okay? The make was stainless steel, right? So you need to be able to give example. Brass, to know copper and what? Zinc, right? I giving you bronze and tin and steel rather. You need to know this example like white hat, know them, okay? Then the second learning outcome states that alloys can be harder. Okay, so I said they are mixture. The question is, how do they mix them together? Okay, it's just like if you have white, I don't know if there is white chocolate. Is there anything like white chocolate? Okay.
Yes, sir.
Okay. So we have white chocolate, brown chocolate, black chocolate, and everything. If you want to mix them together, right? You just pour them and melt it together and stir it. The same way we make alloys. We'll melt metals together because they need to, the atoms of each of the metals needs to lock with one another. So alloys are made by what? Melting different metals to work together. Okay, that's how they make what? Alloys. Okay. Learning outcome 2 states that alloys can be harder and stronger than what? The pure metals and are more useful. They're just telling us, why do we make alloys? We make alloys so that we can get better work properties. So if you mix two metals together, right? One is strong, okay, but does not have resistance to corrosion. The other one is light, is lighter or less strong, but that resistance to corrosion. When you then mix them together, you then have a third metal, not a metal now, a third particle or substance rather, that has the combined property. It's almost like hybrid. Yes. So alloys gives you hybrid world properties, right? That's what alloys, do. Okay, so describe the uses of alloys in terms of their physical properties, of course, like steel, for example. Okay, iron and steel. Steel is stronger than iron because they add what? Carbon to iron to make steel, right? The more the carbon component in steel, the stronger the steel is, but the more brittle it becomes, the harder. Yeah, those are the right words, because something can be strong and not be hard. Yeah. So something can be hard and be brittle. For example, a piece of glass. Glass is hard, but it's not strong. Do you guys agree? Glass is, if it falls down, it's going to shatter. But if I take a piece of cloth, let's say towel, right? Towel is soft, but it's strong. So you should know when you are using hard, soft, strong, strength. A towel can be used to tow a car. Can be used to tow a car, and it's that strong, but it's soft. So know the difference, right? So the more the carbon component of steel, right, the harder it becomes, and the more brittle it becomes. It's something that you guys can easily understand is when I use your pencil. Pencil we call HB. If you see your pencil, we call 2HB. You see HB pencil, then you have B and you have 2B. You guys know pencil. Those of you who do art, you have pencils like this, right? Yeah. So that
Yes,
B
sir.
means brittle. The one that is too brittle, that is 2B, too brittle, meaning that the pencil can quickly finish. You use those one for shading, light and shading line. But the ones that are HB, hard and brittle, then we have pencils that are 2H. Okay? Yeah, so those ones, when you sharpen them, you can use them for 2 weeks. But when you take a 2B pencil, you sharpen it every now and then. So that's the idea we are looking at here. Okay, so alloys have different uses. Like they use your stainless steel. Where do they use stainless steel? For cooking pot, for spoons, for cutleries, and all that, right? That's where they use stainless steel. Even though it's hard, it's strong, but it's not what it will not corrode. It has high resistance to corrosion, right? Now, the big thing about alloys is you understanding this diagram. They can draw diagrams even in the objective questions and ask you which of these diagrams represent what? represent alloys, right? So diagrams for a pure metal, you notice that all the atoms will be of the same what? The same size. Will be of the same size. This represents a pure metal. But a diagram that will represent an alloy, right? The atoms will not be of the same what? Of the same size. Can you see that? It will not be of the same size. So we know, oh, this is an alloy. What does that mean? The different sizes tells you that you have atoms of different metals that are what? That are connected together, that are mixed together. Okay? So, and this is why alloys have what? Have, higher strength compared to what? To pure metal. So you can see the fifth learning outcome there. It says, explain in terms of structure how alloys can be hard or harder and stronger than pure metal, because the different sized atoms in alloys mean the layers can no longer slide over one another. Remember malleability, right? We said metals can slide, the upper layer can slide over the lower layer. That is when all the metals are of the same word, the same size. But the moment the sizes differ, right, the upper layer would no longer be able to easily slide over the lower layer. It's almost like you want to run your skateboard, right, on a smooth ground. You can move. But when you want to run it on a ground that is not smooth, you know how difficult it could be, right? The tire could get hooked here and you'll not be able to move. That means that it's no longer malleable, right? It can no longer slide over one another. And if it can no longer slide over one another, it's going to be hard, right? That constitutes to the hardness of the metal. Okay, so this is why alloys are stronger and harder than pure metal. Apart from the fact that if you use mixtures of metals that are resistant to corrosion, like chromium, okay, like palladium, like rhodium, then yes, Farida, you raise your hand.
Yes, I have a question.
Go ahead.
So I wanted to ask, like, if the metal that's added to the other metal for it to become an alloy, like if it's smaller, will the same principle still apply?
Yes, if it's smaller,
Like if it's a smaller size.
yes, the issue here is that they have different sizes. Do you understand? When you say it's smaller, that means one is bigger than the other.
Yes.
Okay, so as long as they have different sizes, so what that simply means that the layers will not be smooth. They will not have smooth interlocking. I mean, if you relate to your mathematics, like you know what we call tessellation in math, huh? Tessellation in math.
Sir.
Yes, exactly. The moment the shapes are, and maybe I'm doing tessellation now of a rectangle with a triangle, I have spoiled it. It will no longer be smooth. Do you get that? So the moment one is smaller than the other, it means that one is bigger than the other, right? Then it means that the layers will not be able to slide easily over one another. But the difference in size will determine how hard the alloys will be. Do you understand? So if the sizes are different, one is very big, the other is very, very, very small, then it will make it to become difficult for you to slide over one another. Okay? If you look at the diagrams that we have here, it explains why, alloys, metals are malleable. Okay? When there is a pressure on the metal, the upper layer slide over the lower layer easily, right? That's why metals are malleable and ductile. But when it comes to alloy, you can just see the shape. That big one is making it difficult for the upper layer to slide over the lower layer. Okay, so that means it becomes stronger, okay, than the original metal, than the pure metal, right? You can also refer this to what we call friction. How do we define friction? We say it's a force that opposes motion. You see that? So it means that in alloys you have higher friction, right? But in what do you call it? In pure metal, there is lower friction. Okay, since the friction is lower, it will be easy to slide. right? Just slide and glide over one another. Okay, that's on alloy. Now we are getting to the big one, reactivity series. Reactivity series. Now, I know a whole lot of you missed classes on this reactivity series. So I'll put the learning outcome there one after the other, and I'll just explain them on and on. But before I move on, does anybody have questions on metals, properties, and all that like that we have looked at before I move on quickly? No one? Okay. So the first outcome here says that you should be able to state the order of reactivity. It says state the order. So this might implies that they want you to memorize this. They say you should be able to state the order of reactivity as, can you see that? Meaning that you are starting from potassium, calcium, potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, iron, hydrogen, copper, silver, and what? Gold. So you need to know that order. If you are going to use something that a song, a mnemonics, a rap that will help you to remember, please do. You are supposed to know this, right? But this is called reactivity series of metals. But you'll notice that we have two non-metals here. What are the two non-metals, everybody? Someone, what are the two non-metals? Carbon and what? Hydrogen, right? Good. Now, it's very important. Their position will determine certain reactions. For example, reaction of metal with acid. Okay, that will determine that. Then position of carbon will also determine what? Extraction of metals and what? And displacement reaction. So it's important for you to know. So let's take the first group of metal, most reactive metals. Potassium, sodium, calcium, magnesium, aluminum. After aluminum, then we have what? We have carbon. We have carbon. So carbon comes after what? Aluminum. So it means that carbon is more reactive than zinc, iron, tin, lead. Then immediately after lead, like we have hydrogen. It means that hydrogen is more reactive than what? Than copper, than silver, and what? And gold. These ones are least reactive what? Least reactive metals. Okay, so you can see here, it says metals above the blue line, that is above this place, okay, can't be reduced. Okay, I mean, carbon can't reduce their ore, right? So what it means that all these metals are what? They are more reactive than carbon. So carbon cannot reduce them from their ore. That means carbon cannot displace them. You understand that, right? Carbon cannot displace them from their compound. Now, these metals can be displaced by what? Can be displaced by carbon from their what? From their ores. This metal can be displaced by carbon from their ore. And if you remember the extraction of iron, iron is extracted by what? Reduction with carbon, because carbon is higher than what? Than iron. So if I have iron ore like this, and I react with carbon, oh, carbon is powerful than iron. It can kick away iron, okay, and collect the oxygen from what? From iron. You can have carbon dioxide or carbon monoxide plus what? Plus iron. This is called a displacement reaction. I'm just introducing to the use of this word, reactivity word series, right? Then here we can see hydrogen. See hydrogen there. Any metal that is lower than hydrogen in the reactivity series will not react with acid. Will not react with acid, and neither will it react with water. How? You know, we look at the reaction of metal with acid the other time, right? We said metal plus what? Acid forms what? Salt plus what? Hydrogen. What does that mean? It means that hydrogen will be displaced. A metal that will displace hydrogen will be a metal that is higher than hydrogen in the reactivity series. So copper, silver, gold are lower. So if I do copper plus HCl, they will ask you whether the reaction is feasible or not. It's not what? Not feasible. Meaning that what? It cannot occur. Why? Because copper cannot displace what? Hydrogen. Copper is lower than hydrogen in the reactivity series. Okay, so that's the use of reactivity series, right? Of metal. So you need to know this position, right? We start from potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, hydrogen, copper, silver, and what? And gold, right? Good. Now, would I want to see in details reactivity series? Describe the reactions, if any, of potassium, sodium, calcium with cold water. So you can see that these metals are higher in the what? Reactivity series, right? They can react with cold water. Potassium, sodium, and what? Calcium can react with cold water. Please focus on this. It's very, very important. You can't escape this. Potassium, sodium, calcium can react with cold water. We already look at the reaction. What will be the product of these metals with water? Is it hydroxide or oxide?
Hydroxide.
Hydroxide plus water, right? It's going to form what? It's going to form hydroxide and what? Hydrogen. You can see, right? That is group 1. All group 1 metals will have the same way. All group 2, represented by calcium, will be the same thing. Sometimes they can write an equation and tell you X. They can say a metal X in group 2 react with water. Write the equation. And so you'll be wondering, what will you do? Since they say it's a compound X in group 2, it's going to be similar to calcium. So I can say X, right, plus water is going to give me what? X hydroxide. Can you see that? Plus what? Plus hydrogen. Then I balance the equation. So don't get lost. Don't say, hey, we don't know this. Just flow, right? Flow like liquid. But don't have the localized electron. Okay. So magnesium plus tin. We looked at that earlier, right? So you can now see why magnesium can react slowly with cold water, but react vigorously with what? With steam, right? So look at this table. Very important. That table will help us to understand this outcome. So they differentiated all the metals, okay, into 3 parts, like those that can react with cold water, those that can react with hot water, and those that will not react at all. Okay? They say explain these reactions in terms of the position of the metals in what? In the reactivity series. So you can see, so out of all of these metals, right, this will react with water, whether hot or cold. This will react with water, whether hot or cold. This will react with water, whether hot or cold. Magnesium will react well with what? With hot water, right? Zinc, iron, right? But the moment you get to copper, these guys will not react. Why? Anybody want to tell us why will copper, silver, gold not react with water?
Because they are lower than
Because they're
hydrogen.
too.
They're lower than
They
hydrogen. Yeah,
they
because
can't
they cannot
displace.
displace hydrogen, right? So it's the same thing. So however you want to put it, right? They cannot displace hydrogen because the reaction must release hydrogen and they cannot displace hydrogen, right? So no reaction. And the same thing with what? With acid. Reaction with acid too will form what? Salt and hydrogen. As long as the metal cannot displace hydrogen, there will be no reaction because the metal is lower than hydrogen in the reactivity series. Okay, so that is what you have this representing. Please, if anyone has question, I beg you, please ask me. Please. So you can see this potassium react vigorously. Yes, I remember. Another thing that you could be asked here, apart from telling you whether you react quickly or slowly, they will tell you what can be observed. What can be observed? For example, what can be observed when potassium react with water? So you are describing it react vigorously, right? Yes, or it fizzles, okay? Effervescence, meaning a gas is produced, right? It can catch fire, explosion can occur. Do you understand? Then you can tell them that the potassium will dissolve because if the potassium reacts, it's going to dissolve away, right? The potassium dissolve. So these are physical things that you can see, right? They can take you as far as linking it to acid, base, and salt. Now, let's look at it, everybody. If potassium, right, potassium react with water, okay, and they add blue litmus paper, they add or red litmus paper to the water. Let's say this is the water, right? They have red litmus paper here, and they now throw potassium into the water. They say, ask you after a while, what will be observed? Anybody? What will be observed?
The red litmus will turn blue.
Yeah, the blue litmus, the red litmus paper will form what? Will change to what?
Blue.
To blue. Why? Why will it change to blue?
Blue.
Because potassium hydroxide.
Fantastic. Fantastic. Because potassium hydroxide is an alkaline. So it's now going to change the litmus. So they can change your indicator. They can give you methyl orange. Can you see? So you need to know the color of your indicators. Go and search your textbook. Phenolphthalein. What is the color in base, in acid? Colorless in acid, pink in base, and methyl orange. What is the color in base? What is the color in acid? Litmus. What is color in base? What is color in acid? Go and know that. They can link this to what? To acid, base, and salt. Do you get that? So questions underneath this, you need to be able to write equation, balance equation, and of course, link it to acid, base, and what? Acid, base, and salt. So that is this reactivity there. You can see these metals will not work, will not react because they are lower in the what? In the reactivity series. They cannot displace what? They cannot displace hydrogen, right? Why these metals form insoluble what? Oxide. Can you see? Can you see the difference? Oxide, oxide, oxide. Why this other one form what? Hydroxide. In fact, that is why they are called alkaline metals, right? Because they are, when they react with oxygen, their oxide can dissolve in water to form alkaline. They are called alkaline what? Metals or alkaline earth metals, group 1 and group 2. Okay, so you need to know the difference there. Reactivity series you can use to explain reaction of metals with oxygen, reaction of metal with acid, reaction of metal with what? With water. So I want to look at here. This is reaction with acid. Reaction with acid. So you can see all other metals will react with acid except what? These metals that are low in the what? In the reactivity series. They cannot displace what? Hydrogen from the what? From the acid. And so the reaction is not going to what? Take place. But every other metal will react. But there will be difference in their reactivity. Reactivity simply means the speed with which they react, the manner in which they react, right? For example, you will not compare the way magnesium will react with acid with the way iron will react with acid. Magnesium will be faster than what? Than iron, right? And that means it's going to form more bubbles per time. It's going to produce greater volume of hydrogen per what? Per time compared to what? Compared to iron. Okay. Now, I want to link this reaction to displacement reaction. Displacement reaction would then link it to redox. Okay. So you need to be able to define displacement what? Reaction. Define displacement reaction. So who is defining displacement reaction for us? Displacement reaction. Anybody?
Is a reaction where a more reactive element like it kicks away a less reactive element.
Okay. A reaction in which a more reactive what? Atom,
metal,
okay, replaces a less reactive atoms or group of atoms from its what? From its compound. That is called a what? A displacement what? Reaction, right? Good. Now, metals that are highly reactive metals, they want you to be able to link it to the tendency of metal to form positive what? Positive ions. So that means let's look at calcium and what? Magnesium. Which of the two do you think has a higher tendency to form positive ion? To form positive ion means that can lose what? Can lose electron, right? Calcium can lose electron to form 2 plus. Magnesium too can lose electron to form what? To form Mg2 plus. But calcium can do it more readily than what? Than magnesium. So magnesium is less reactive than what? Than calcium. While calcium is more reactive than what? Than magnesium. Okay, so I will go back to this displacement reaction. I will use hydrochloric what? Acid. Let's say zinc, zinc now, okay? Let me say zinc plus HCl, right? To form what? Zinc chloride plus what? Hydrogen. We'll balance it. So this is a displacement reaction. Why? Because zinc took the place of what? Of hydrogen. That means what? It means that zinc displaces what? Zinc displaces what? Hydrogen from its what? Compound. And what is that compound? HCl. So that tells us that zinc is more reactive than what? Than hydrogen. Now, what else can we say about this reaction? This reaction is not just a displacement reaction, because they can write a reaction and ask you, what kind of reaction is this? Explain, right? This is a displacement reaction, but also it's a what? It's a redox what? Reaction. So I want somebody to tell us, in this reaction, what is the oxidizing agent and what is the reducing agent? Anyone? What is the oxidizing agent and what is the reducing agent? Please focus on this, or you will do a lot of this.
Zinc is the reducing agent and hydrochloric acid. Sorry, hydrogen is the oxidizing agent.
Hydrogen is oxidizing agent.
No, zinc is the reducing agent
Yes, zinc
because
is
it's oxidized.
yeah.
Okay.
And then hydrochloric acid is the oxidizing agent
So-
because it's reduced.
Because it is reduced. Okay. So let's look at it. Now, hydrogen can never be your agent because it's a product. That's one of the way to know, right? Your reducing agent or oxidizing agent will be either of these guys. Will be either of these guys. Can you get that? Okay. So let's go back and to use our methods of identifying oxidizing and reducing agents, right? To know this. So I'm rewriting the equation zinc plus what? Plus hydrogen, okay? To form zinc chloride plus what? Plus hydrogen. Now, I will use this reaction to also show you how to write redox equation and how to write ionic equation. Please, everyone focus. How to write redox and what? Ionic what? Equation. So I have 6 minutes before timeout. So here, let's write the ionic equation for each of these guys. Let's break them down. Zinc is zinc, right? Because it's solid, isn't it? It's just zinc, solid. This guy is aqueous. It means you can break it down, right? So hydrogen is usually +1, isn't it? Can you see? Chlorine,
yes, sir.
Chlorine would then be what? -1, right? Because it's what?
Minus.
Yes. It's group 7. So zinc here, we don't know what this guy zinc will be. We know that chlorine is -1, right? Chlorine is -1. So what we chlorine is -1. So zinc will be what? That's yes. So that means I'm going to add Zn2+. Can you see the way we break it down? Zn2+ plus what? This guy is H, hydrogen. He's standing alone. Okay, good. So what's the oxidation number of zinc here? 0. Who can tell us the rule that gave us that? What rule? What rule gave us that?
Any element in their uncombined state is
Is 0. Okay, hydrogen here is what? +1, right? Chlorine here is -1. Zinc here is what? +2. Chlorine here is what? -1. Hydrogen here is what? 0. Now, if they ask you to write the ionic equation, right? So let me quickly do the ionic equation here, then I may erase it. Ionic equation means that you are going to write everything the way they are. Let me do the ionic equation in this box. Okay, write everything the way they are, but you remove the spectator ion. Then you ask yourself, what are spectator ions? Ions that remain unchanged, -1, -1. Can you see? So I'm canceling the guy. So that means I'm left with what? Zn plus what? H plus, right? That means I'm to balance in my equation, right? H plus, that means it's 2 of these, right? To give me what? Zn2+, right? Plus what? H2. This is my ionic equation. Can you see that?
Yes,
okay. So if I have that now, I can then know which one is oxidized and which one is reduced. That is why using oxidation number to know redox is better than using electron loss gain or than using oxygen gain or loss. For example, this reaction, there is no oxygen gain or loss. and I cannot easily see which one is losing electron and which one is gaining electron from the equation. I can't see it except it is written.
Mhm.
So the easiest one is quickly find the oxidation number, right? Then look at
Yes,
it.
sir.
It moved from 0 to what? +2. That's an
+2.
increase in oxidation number, right?
Yes.
Increase in
Yes,
what?
sir.
Ox number. That must be what? Oxidation,
Oxidation.
right? Let's check the other guy there, okay, which is hydrogen. It moved from +1 to what? To 0.
0.
So that's a decrease, right?
That's reduction.
That's reduction. Easy. So how do you know that oxidizing agent and reducing agent? Oxidizing agent, right, becomes what?
Reduce.
Oxidizing agent becomes reduced. So oxidizing agent is reduced. So which one is reduced there? Hydrogen ion.
Hydrochloric acid.
Yeah. So I will answer that. So there are two ways you can now answer that question. Because your hydrogen ion is gotten from hydrochloric acid. Therefore, you can say your reducing agent is what? Hydrochloric acid or hydrogen ion, not hydrogen. Are you getting my point?
Yes, sir.
Okay. I'm hearing only one voice. Please, you guys should speak out. Don't
Yes,
take
sir.
everything hook, line, and sinker.
Yes, sir.
Yes.
Yes, sir.
Don't take everything hook, line, and sinker, except you are a fish. But I'm not a fisherman. Okay. So reducing agent here is what? HCl, or what do you say? Hydrogen what? Ion. Can you see that? Why oxidizing agent is what? Oxidizing agent is what? Zinc. Can you see? Zinc. Okay. So when we come back from the next interlude, we'll now look into competition between what? Between ions, or competition between metals. That would have take us to extraction of what? Extraction of metals. And I think the next lap should be maybe our last lap. So that will take us to like 6:30. You guys have tried. I guess this is the longest lecture you've ever taken. Okay.
Yes, sir.
Yes, sir.
Okay. So please ask question. I have 1 minute before your time is out. I just wanted to cover what you need for, so that you will smile in your exam. Okay,
And so, sorry, I have a question.
please go ahead.
Okay, so like let's say like we have an MCQ question, right? And if it's MCQ, it's going to be four it's going to be four options like A, B, C, and D.
Yeah.
And they ask us to identify like which one is the redox reaction. Like it would be tedious to do this for like all four of them. So is there like a shorter way we can find which
Yes,
one is the
yes.
redox
Number one,
reaction?
you need to practice this so that you can do it with speed. Number two, they will mix the equation such that some you can easily see oxygen loss, oxygen gain. You eliminate them. The ones that you don't have oxygen there is the one that you will need to do oxidation number. The moment it has oxygen, it's easier. You just look at it on the other side. It has oxygen here. For example, if I say zinc oxide, okay, and the other end I have zinc. So I know that zinc oxide has been what?